Hello, Science 8. So today we will be talking about plate tectonics. So first off, I want you to know that continental and oceanic plates move and interact. And this movement and interaction causes geological features and events such as volcanoes, mountains, valleys, trenches, ridges, and earthquakes. So, what is a plate boundary? A plate boundary is where plates meet and interact. And there are three types that we're going to learn about today. There are divergent boundaries, convergent boundaries, and transform boundaries, also called faults, which will make this joke that I'm about to tell a lot better. So we have a little fishy here that says, two tectonic plates bumped into each other. One says, not my fault. Get it? Because transform boundaries are called faults. It's funny. Trust me. Then this one down here says, there's just too much friction between us. And then the other plate says, it's not my fault. Get it again? Because fault. You'll get it in a minute. It's very funny. And as you can see, throughout the world, there are many different plates. So we have the African plate, the Australian plate, the Eurasian plate, the Indian plate. There's just so many all around the world. And these plates interact and meet and create different kinds of plate boundaries. So let's investigate a little bit further. Alrighty, so the first kind of boundary is divergent boundaries. And these plates move apart from each other. Apart. So you can think of divergent as divide because the plates are dividing. They are moving apart from each other. And once these divergent boundaries, these plates are moving apart from each other, magma is coming up where the gap is formed, and it cools off, and this magma, once it's cooled off, becomes new crust. And this usually happens in oceanic plates. All right, so if we look at the picture over here, we can see that these two plates are moving apart. And then you can see that the magma is coming up through here and is then cooling, usually because of the water. And it is cooling and becoming new crust. And so the newest crust is always where those two plates meet. And an example of this is the African Rift Valley. And this is a result of a divergent boundary on land. So as you can see, these two plates are moving apart, and which is why there's a big gap there. All right. So next we have divergent boundaries. So convergent boundaries. Silly me, we just did divergent. We have convergent boundaries. And convergent boundaries, the plates move towards each other. So they're over here and they move towards each other. And you can think of this as convergent. The plates collide. So convergent, collide. So you have the plates and they are colliding. All right. And when these plates collide, the more dense plate subducts or sinks under the less dense plate. And I'll show you what I mean by that in a second. So there are three types of convergent boundaries. Now the first one that we're going to go over is oceanic and oceanic. So this is where two oceanic crusts collide. So these are both only oceanic, so one is not more dense than the other. So what happens is these two oceanic crusts collide, and usually one is more dense than the other, so a little bit more dense though. They're both oceanic crusts, but one is probably a little bit more dense than the other. And so the one that is more dense, or just the one that gets there first, it subducts under the other oceanic crust. It goes under it, subducts, And what happens is, as you can see from this picture, this oceanic crust was subducting under this oceanic crust. And what happens is that this creates volcanic island arcs. And I'll explain to you how it creates the volcanoes in a second. And what volcanic island arcs are there little volcanoes in the middle of the ocean. An example of this is Hawaii. As you know, Hawaii is basically in the middle of the ocean, and it's just little volcanoes all in the ocean. And these also cause trenches because, as you can see, one of the plates are subducting under the other. All right, so the next example is oceanic and continental. So oceanic crust is more dense than continental crust. So when these two crusts and plates collide, the oceanic crust is going to subduct under the continental crust. And what happens from this is that magma is created from the melting of the oceanic crust, and magma is formed. So the magma is created, and then it comes up, it rises up and creates volcanoes. So this collision creates volcanoes, but also the magma that we see come out of volcanoes comes from this oceanic crust melting, then it rises up and comes out of volcanoes. And this also happens, as you can see, in the oceanic to oceanic example, because both form volcanoes, but the oceanic to oceanic forms island arcs, which means volcanoes that are in the middle of oceans. And the oceanic to continental just causes regular volcanoes. And an example of this is Mount St. Helens, which is a big volcano. All right. And then last but not least, we have continental to continental, which are two continental crusts colliding. Now, as we know, continental and continental have the same densities. So when they collide, they do not subduct. They collide and they go up. So they collide and go up. And what this creates is it creates a mountain. So they collide and they move up, which creates a mountain. As you can see, this kind of looks like a mountain. They collide and move up like a mountain. An example of this is the Himalayas. So, as you might know what the Himalayan mountains are, those were created from a continental to continental convergent boundary. Awesome. Okay, so the last kind of boundary is transform boundaries. And this is when plates slide past each other and create friction between the plates, which can cause a sudden release in energy, which causes earthquakes. So what I want you to do is I want you to take your two fists and I want you to interlock your knuckles between them. So they're like this. So your knuckles are like in the little holes here. Put your knuckle in between. And I want you to try to, it might hurt a little bit, so be careful. I want you to try to move your knuckles together. And when you're doing this, you're creating friction, which causes energy release. And as you can feel, it's creating a lot of rough motion between your knuckles. And this is basically mimicking an earthquake. So when the two plates, as we can see here, as the two plates slide back and forth between each other, it creates friction and causes a release of energy, which causes an earthquake. So as you can see, there are earthquakes, which are represented by these orange little dots. And an example of this is the San Andreas Fault. So I am going to save you from my voice, my singing voice, because as you know, it's not very good. So I found a short little video of a song that is to the Addams Family theme song, which I hope you have all seen because it's great. And it helps you remember the three kinds of boundaries. So the three ways that they help you remember is divergent is dividing, convergent is colliding, and transform is sliding. So let's see them sing it for us.
Convergent is colliding, divergent is dividing, transform is sliding, they are the plate boundaries. Convergent is colliding, divergent is dividing, transform is sliding, they are the plate boundaries. Da 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 da, da 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 da, da 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 da, da 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 da, da 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 da.
All right, so that I hope helped you a little bit, and I hope you can keep that in your brain when you're trying to remember what the different plate boundaries do. Oh, you know, I'm going again. All right, go. Okay, there we go. So now we have an informational video on plate tectonics that will help you understand these plate tectonics even further. So enjoy. And I promise you there's a really fun music video at the end of this. I won't forget about that. Promise you.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other. As the edge of the sea floor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
So, next, as always, we have a fun video for you. And of course, it's a song, because I love when you guys get to listen to songs. All right, so here it is. Enjoy.
Did you know those plate tectonics move real slow? There's convection in the mantle and it makes it go. Hot magma rises up above and cool rock sinks below, and it causes plate tectonics. Here we go. Well, I bet when you feel an earthquake, it makes you wonder why the earth shakes. And I'm betting that by now you know exactly how the crust is broken into plates. Some plates spread apart, they're divergent. Some plates move together, convergent. Transform faults are slipping and sliding. The rocks grind together, not gliding. Oceanic crust is the densest of the crust, but the continental crust is thicker and taller. The
Pacific plate's massive, yeah, hollow, but the Wanda Fuke is smaller. Plate tectonics move real slow. There's convection in the mantle and it makes it go. Hot magma rises up above and cool rock sinks below, and it causes plate tectonics. Here we go. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics, like everywhere they go, they're making the lava flow, like on the ocean floor or in a volcano, like the pyroclastic flow from St. Helens years ago, or at Pinatubo. If there's ash, you better go. Composite eruptions are fast, they are not slow. Composites, also known as a stratovolcano. Mauna Loa is a shield with a slower lava flow. Cinder cones are very small with a crater blowhole, where there are hot spots where the mantle breaks the crust and there's subduction, where you can get a megathrust mid-ocean ridges. That's where the mantle pushes up, that's how they do it. Now you know how plate tectonics move real slow. There's convection in the mantle and it makes it go. Hot magma rises up above and cool rock sinks below, and it causes plate tectonics. Now you know. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Earth's system's like a circuit. Let me see your brain and how you work it. With evidence now you can discern it, 'cause I love the way you learn it. Let me see those brainwaves grow. Gotta let those brainwaves grow. Learn about those plate tectonics move real slow. There's convection in the mantle and it makes it go. Hot magma rises up above and cool rock sinks below, and it causes plate tectonics. Now you know. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics. Plate tectonics.
Alrighty, well, I hope you enjoyed those videos and learned a lot about plate tectonics and thought it rocked. I'm never going to stop saying that joke as long as we're in our geology unit. Alright, that is all for today, and I hope you have a lovely rest of your day. Goodbye.